Welcome back, my dear friends, participants. A very good morning, good afternoon, good evening to all those who are attending this course under MOOC-NPTEL series. And this title of the course, as you know, is Application of Forecasting Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you know, this is the continuation of the set of lectures, three broad topics: averaging techniques and forecasting, multiple linear regression, and then last part being time series analysis. And here we are covering the first part, which is averaging techniques and forecasting. So, this is week 1, third lecture, and what we did in the second lecture was basically trying to follow this, how the steps of forecasting techniques are followed. What are the two different main concepts of forecasting? One being qualitative and quantitative. In qualitative, the ideas of very simple ideas of Delphi, expert opinion, brainstorming I did mention, even though I had requested that you please go through in a good book to understand that as the main focus for this set of lectures or this course is more quantitative. Then in quantitative, we followed that how what would be basically the ideas of followed for doing a forecasting. We basically describe the problem, collect the data, clean the data, analyze what matrix to use, which gives you the best result, and then try to find out that how would the prediction be in the future depending on the information set which is there. And we are also going to discuss time and again, which we did, that if there is a missing data based on either an average value or there are outliers we have to remove depending on variability, you have to consider that cleaning of the data is needed. I am just mentioning it. So, because for all the information which we are going to use, the data set we are going to use, such cleaning of the data may not be required, because that will take much long discussions for this course. So, I will try to avoid that. Then once the cleaning of the data is done, then the steps are followed, which I had described in the second lecture of week 1. So, what would be the coverage of this lecture 3? It will be types of forecasting which are used. What are the numerical methods analyzed for forecasting, how you analyze the forecasting technique, under which circumstances, which assumptions, what can be the error, because the main task, as you understand, is basically to minimize the error of forecasting, and what are the metrics of forecasting. So, this we will try to cover in the third lecture. So, what are the different types of forecasting? So, they can be graphical plots. So, graphical plots, if you remember, we had discussed the ideas of time series data, where time series data in not in the sense that this is we are going directly in for the third component of this set of course. Time series in the sense that along the x axis you are using time to be measured, and along the y axis the variable or the data you are trying to utilize. So, there can be graphical plots. Graphical plots in basic statistics can be anything. It can be pie charts, it can be bar diagrams, stack diagrams, many things. So, graphical plots can be there along with time series, time plots is there. So, one type can be horizontal, where stationary in its mean. So, if you remember time and again, two words I am utilizing. One is mean value, trend value, and is variability. Mean is basically simple, the expected value average, and the variability is very simply the variability or the variance. So, if I consider these combinations, so trend can be increasing along with variability constant, trend can be decreasing along with variability constant. Then another case, you can have trend increasing with variability increasing, trend increasing with variability decreasing. Then another can be with trend decreasing, variability increasing, trend decreasing, variability decreasing. So, if I consider all the, and obviously it can be, the simplest case can be where trend and variability both are fixed. Now, the main emphasis for this forecasting one, which is an underlying assumption which is very important, is that we will consider variability does not play that big a role, or else we have to basically go into realm of time series, which we will consider. Then the graphical plots, time series and time plots. The other type is seasonality or periodicity. Cyclicity is not the same right word. Then you can have cyclicity, then you can have trend for non-tertiary, which is for the case where mean is not fixed. So, the words which are important, which I will highlight, are like this. I will use the orange color. One is seasonality, where seasons are there and periodic, and they follow a certain pattern. It can be quarterly, monthly, yearly, depending on. Obviously, if I consider the seasons, there are 4 seasons: summer, winter, spring and autumn, if I follow the Gregorian calendar concept. But if I consider the Indian type, you will basically obviously have in different areas, summers would be much more than the winters. So, if I am paying attention to the part of UP as such, the summer part would be much more, in the sense it will start from March and go on to with the rainy season, it will continue to about September, and then October, November, December you will have the winter. So called fixed definition of summer, winter, autumn, spring may not be applicable. So, if I consider that concept, so each is of 3 months, 4 into 3 is 12 months, which is 1 year, that may not hold. So, you have to be careful when I use the word seasonality. But if I consider the concept of cyclicity, that concept of cyclicity, that how the cycles move, if I am considering the sale of gold during Dhanteras, sale of gold during Diwali in northern part of India. Similarly, for other festivals, it will be in southern part or on the eastern part or western part of this country. So, there would be a cycle. So, if I consider the concept of Dashera or Durga Puja in West Bengal, so it will be between end of September to middle of October. So, each cycle is accordingly. So, it is definitely depends on the Hindu scriptures, Hindu time, the calendar, but cyclicity would be more important word and more important concept to consider there. Similarly, for, as I said, for Diwali, for or Onam, or for any other festival. And when I am considering the concept of trend, non-stationary mean, if you have seen for the case of food production, there was a increasing trend. Even though I did discuss, I am not going to discuss it again, because if you go through the lectures, you will understand that it was divided into 2 distinct time frames, 1950 to 2000, 2000 to 2020. So, there can be seasonal plots, there can be scatter plots, and they can be different type of summary in concept or numbers. So, it will give you a better idea. So, our main emphasis in the forecasting would be, I am going to use the red color, would be in these, where seasonality, periodicity, cyclicity, trend and all these things basically are, it is something to do with expected value. I am using the red color here. Mean. So, this is for the mean. If I use the concept of cyclicity and seasonality, so they are something different. Obviously, I am using the same color, for green for periodicity, and let me not use the same color, my apologies, I will use violet for cyclicity. So, it will have a different idea. And obviously, in all these things, variability will also be there. So, we will mainly emphasize on these ideas, which is basically trend, periodicity, cyclicity in the forecasting sense. Now, this is the third example. We are encountering third example, and here is basically a simple plot. So, it gives you gold, silver, bronze in Olympics starting from first day till 2020 for USA, USR. USR basically is the erstwhile CCP, then Russia. Then you have Germany. Germany would basically be West Germany before the communist regime was dismantled, while after the communist regime was no more, it was basically the unified Germany. I am just giving you informations. Then GBR is Great Britain and CHN is China. So, if I have gold, silver and bronze for different countries, so along the path, if I consider, so you have USA, I will use a red one. So, this is for USA, I will mark it here. If I use the dark red one for USSR or USR, if I use for Germany green, if I use for Great Britain light blue, and finally, so it is light blue, and if I use violet for China, so Chinese data is here, all gold, silver and bronze given, gold being blue, silver being orange, bronze being grey. Similarly, for Great Britain, this is the one. Then you have Germany. So, in Germany, the number of gold, silver, bronze are almost the same. Even though if rather these the big dots, if they are dot points, it would be much more easier to understand the difference between gold and silver. So, if I consider, say for example, for Germany, and the line being for Germany being in such a way that the value comes out to be on approximate about 300 for gold, then 300 for approx 300 silver and 300 bronze. So, if I consider the concept of USSR, it is here where the number of golds is much higher. So, golds we consider would be touching about 500 approx again. But if I consider, say for example, silver, if you see it, when you have the slides you will understand. So, silver will be little bit less than 400, while bronze would be much less than the number of total number than silver. And if I consider for so say for example, here for number of golds for US or USR would be approx, gold will be approx about 475, then silver would be about 390, these are approx value, and this would be about 375 total. While I consider USA, so about value would be touching 1150, then silver would be about 950 and bronze would be about 825, and this would basically be for USA. So, what does it give? It gives us that pictorially how we can find out the total, and if I have, so these are collective. I am not considering across the Olympics. If I see it individually, I can predict or forecast depending on the number of games that what would be the approx number of gold, silver and bronze won by these three major countries who basically top the list. This is just a way of prediction, depicting. Prediction has not been yet taken. Now, some of the numerical characteristics which are used, these are characteristics, I will just consider them accordingly. So, here this is very simple. As we proceed, we will analyze it. So, the first one is basically I will highlight is the mean of the sample. Now, let us not be too finicky about the concept of mean of average of a population or mean of a sample and all these things. They are under the domain of theoretical statistics, and if you follow the course which I teach in NPTEL, which is DADM 1, 2 and 3, data analysis and decision making. Part 1 basically considers in details about statistics. So, there is 3-part course. If somebody is interested, he or she can definitely take that course or set of courses. So, if I am talking about the mean value, so the mean value would mean that I add up all the values. So, y I am trying to replicate as the data which I am plotting. So, say for example, y1 is equal to 10, y2 is equal to 25 and y3 is equal to 20. Then the value, and there are 3 values. So, n is basically what? N is 3, because there are 3 data points. So, if I basically find out the average, which is the mean of the sample, which is 10 plus 25 plus 20 comes out to be 455 by 3, which comes out to be 3. So, about 18, approx 18 point something. 3 ones are 3, 24, 3 is 24, 10, about 18.3. So, this is the mean of the sample. Now, a point which you would have noticed is basically what is this m. So, let me highlight m basically means the mean, symbol for mean. And why I am using that? Because if you see the suffix m is for the mean, and why I am using that, be careful about that. The symbol of mu which is used, so mu is basically the symbol which is used for the mean, for the median and the mode, and the corresponding suffix when I am using the concept of mean, it will be denoted by m. Similarly, when I am utilizing the idea of median, it will be suffix e. I am using a different color, notice it here, e. When I am utilizing the concept of mode, again I use a different color and mark O, which is for the mode. While the suffix y basically means the variable which depicts the data, and if I consider the hat which is there for the mean, median, mode is basically the estimate which I am getting from the sample, not the actual value from the population. So, I said that do not be too much bothered about the nitty-gritties from the statistics point of view. The idea is basically to understand the forecasting techniques. Obviously, if we try to utilize the ideas from statistics and forecasting, it would definitely make much better sense. But considering that you would have done DADM 1 or any of these courses which are there, the idea would be much more clear to you. So, if I use the median, so here if you consider, before I go to the median is basically the central value. Central value in the sense that in the case when I am considering the mean, the corresponding occurrence of these values of 10 is 1, 25 is 1 and 20 is 1. So, that is why I considered the probability or the chance of picking up any one number is 1/3. In case, say for example, the numbers were, I will use again the same color red. So, if it was, and it is one value, consider this was the case, this was the case, this. So, this was the analysis, and this value was, say for example 10. So, this so y 1 was 10, y 2 is 25, y 3 is 10. So, the total value is 10 plus 25 plus 10, which is basically 45, which is 15. So, if you consider, even though I am dividing by 1 by 3, but the probability or the so called weightages, I am using the word weightages for the first time, it will become clear later on. The weightages of the probability for 10 is by 2/3, which is about 66%. For 25 is 1/3, which is 33% approx. And when I talk about the median, is basically that data point or that point which basically divides the total set of data into two equal halves, which means the total probability distribution, sum of the probability distribution, if you remember, the sum of the probability values is 1. So, that basically divides the total distribution into two distinct halves, such that the probability onto the left, onto the right is 0.5. Now, mean and median values for the normal distribution are same. You would have guessed by that time. But if I am considering the ideas of skewed distribution, skewed to the left or the right, then the mean and the median are not the same. So, basically, if I consider right skewed or left skewed, we will see that the mean and median values are different, and we will see that later on. So, when I consider the concept of median of the sample, we will see later on when we do the calculation. I am talking verbally. And finally, when I consider the mode of the sample is the central value. So, if I consider the normal distribution, the mean, median and the mode are the same. But for the case or central value, or basically in the sense, central, the word I am using in the sense where the probability is the highest or where the frequency is the highest. So, in that case, mode is basically is the general concept which is utilized. So, generally when we are talking about forecasting about the trend, if you remember, we will always be highlighting the mean value, even the mode and median can be utilized later on. I will come to the median and mode later on. Then we will have basically the idea of variance. So, the symbol utilized here, I will use a different color, consider this is blue. So, basically sigma is the basically with the hat means because this is the estimated value, sigma is basically the sample standard error or the standard deviation, and here I will use the consider, say for example, the yellow one, if it is visible, well and good. So, sigma hat y being the variable is basically the standard deviation, it is also given by s suffix y. And if you use the idea of the square of the standard deviation, you have the variance, which is given by s square y suffix y or sigma hat square. Now, very interestingly, the variance is basically found out using this formula, which I will highlight and mark one important point. So, basically you are dividing each individual values dividing by n minus 1. Now, here n is the sample size, why n minus 1? Because you are losing 1 degrees of freedom. It is not that important, but I will just simple mention, it is just for information, nothing to do with this course. So, there would not be any questions about degrees of freedom. Degrees of freedom only will come when you are going into the areas of of regression, remember that. So, what you find out is basically the sum of the squares of the difference between the y and its mean value, not difference between the y and the median, not the difference between the y and the mode, is basically the difference between the y value and its mean value, central value so called. Square it up, sum it up and divide by n minus 1. So, here what you are doing is that in case yi minus the mean value is positive and negative, is being equally penalized in the sense or equally being given in the importance, you are squaring them. Both negative values and positive values when squared basically become positive. So, that is in that sense the concept of in case of forecasting where underestimation is a problem, overestimation is a problem, or forecasting is a problem, under forecasting is a problem, would not make sense. But we will see later on that in there some examples, over forecasting, overestimation, forecasting, underestimation do take importance. So, basically when I consider the variability is given either by the concept of standard deviation or the variance. Now, in the case when n is very large data set. So, dividing by 1 by n dividing by n or dividing by n minus 1, not dividing by 1 by n, basically you are multiplying by 1 by n minus 1 or multiplying by 1 by n, which is technically dividing by n minus 1 or dividing by n. So, utilizing n or n minus 1 would not make much of a difference if the n value is very large. Say for example, hypothetically, say if the value of n is 10,000. So, whether you divide by 10,000 or you divide by 10,000 minus 1, the answer would not be much of a difference. But this is the basically theoretical construct based on which we will utilize the formula accordingly. So, other ideas of numerical characteristics used are, which would be important, would be given a data set of point y1 to yn, we will consider the numerical characteristics as one of them. I will keep tick marking them, and when I use the examples in the later class, 4th class, we will consider that. We will use, I am using the green color only because green and blue would be contrasting, so you can understand. You have the mean absolute deviation where you find out the mod of the difference without the value and find out the sum and divide by n. So, basically that is basically mean absolute deviation. You have the mean weighted absolute deviation depending on the weights you want to assign to the different mod of the difference. Why that comes, we will see that later on when we come to the ideas where immediate past data would make much better sense in trying to forecast. Formulas are written there, do not be too much bothered, check them, but when we use the Excel sheet, it will become clear. You have the mean square deviation values, which is basically, if you remember, we had the ideas of the variance as divide by n minus 1. Here you are dividing by n only, and the sum is basically the square of the difference between the value and its mean value. Here remember mu hat y m is basically the mean value. Mean weighted square value, again you give weightages for the squares of the differences, and these weightages if you see in the slides are k1 and k2, I will highlight that later on. Then you have the basically the covariance of the sample, and you have the correlation. Covariance basically means the relationship between two random variables, where we am taking concept as x and y, but in case of forecasting you may basically need to find out the concept of auto covariances. Auto means with itself, and you have the correlation also. There also you would have the concept of autocorrelation. Here the formulas of covariance and correlations all are given, and they would be highlighted when we use simple Excel sheet to solve them. With this, I will end the third lecture for week 1 and continue more discussion about these characteristics which I have given here, and you can see in the slide with very simple examples using the Excel sheet. Thank you very much and have a nice day.